Alright, so in this lesson we're going to look at some really cool inscribed angles. Okay, pretty easy idea actually. I think you guys will find this pretty simple. We'll see how it goes. Inscribed angle, an angle whose vertex is on the edge of the circle. For example, if we draw an angle in here, it has to be right on the edge of that circle. The intercepted arc, which we've already talked about, is going to be out here. And that's formed where the two rays of the angle meet or touch the circle. Okay. Now, pretty easy relationship between these two. We know we can have angles dealing with the outside of the circle going around 360 degrees. We know we have angles inside the circle. The way it works is this angle, ABC right here, if this was 30 degrees, this is 60. Or going from the intercepted arc back to that angle, you're going to cut it in half. Okay? It's different than when we talked about a central angle. And if this is 30, this was 30. So we have to be careful, and we'll make sure we have that down. So we're going to put this to the test with a couple of problems. I'm not going to be able to keep that up there, but pretty easy idea. Always be careful with what I'm asking you. So to find BW, I'm going to make sure I'm always finding exactly what I want. So I'm going to go ahead and kind of highlight that. If that's 62 degrees, then to find the outside, we're going to do measure of BW is equal to 2 times 62, or 100 and, let's see, that comes out to 124 degrees. Okay, so this would be 124. Pretty easy start. Measure of angle NBC going backwards. Figure out that we're going to take the measure of angle NBC, or the arc out here. So again, we're trying to find this guy. We're going to take that 98 and we're going to slash that in half. So the measure of angle NBC is going to be equal to 49 degrees. Got a pretty easy idea. Okay, find the measure of FB. So this guy here, that arc, and ALB, this guy here, based on the information we have. Okay, so you got to think about what you want to do here. First one is probably easiest, is to think that, okay, 83 degrees intercepts here and here. So this is going to come out to be twice that, or 166 degrees. Okay, so that's from here to there. 130, that's going to help you in a different spot. If we know that's 130, then we know where it intercepts to is right here and right there, or this whole thing is going to be 260 degrees. Okay, so now we have everything there, and hopefully you can see where that's coming from. Hopefully we have everything there, and now we can go ahead and finish exactly what we want. To find FB, this goes back to when we were talking about kind of that little plus little equals big idea. We're going to go ahead and do, so the measure of FB, arc FB, is the whole thing, 260, and get rid of that 166 in there so we can just focus on the other little segment. So 260 minus 166 is going to give us, see, 94 degrees. So that's one of them. So we could also put that here if we want. So that's 94 degrees. To find out ALB, that's actually going to be a little bit easier. We're just going to go ahead and do ALB equals 360 minus, take away that gray part, or 260, which is going to give us 100 degrees. Okay, so again, intercepted arc, it's twice it going on the outside, and then going backwards to the inscribed angle, it's half. Okay, so some of them are tricky where they're overlapping, like 3, 1, and 2, pretty simple ideas. A couple more corollaries. Again, corollary is just something we take as being true because some geniuses, not named Mr. Matheson, a long time ago figured them out. If two inscribed angles intercept the same arc, then the two angles are congruent, and this is going to make sense here in a second. So for example, we're saying that angle B and angle C, we're saying that these angles out here intercept this same arc. Okay, we can see that that's happening. So, pretty easy idea. If this is 100 degrees, we know this has got to be 50, which means this is 50. So, B intercepts AD, and C intercepts AD, so angle B is congruent to angle C. One more of them. If an inscribed angle intercepts a semicircle, think about this. This is really not even something new. It's just based off our theorem. That's why it's a corollary. We take it as being true. Then the inscribed angle is a right angle, or 90 degrees, which makes sense because this guy's 180 degrees, which means going backwards, so that 90 degrees is going to be half. Okay, so again, that's why it has to be true there. So a couple more things we're going to put to use. In number 4, find x. So we have that right there. This is diameter. That diameter cuts this circle into 180 degrees on both sides. Well, if that's 180 degrees going back this way, this guy's 90 degrees. What x makes that happen? Well, we're going to find out. X squared minus 54 equals 90. X squared equals 144. No factoring involved because there's not an x, just an x squared. X is going to be equal to 12. Technically plus or minus 12 because the square root of anything is always a positive and negative version. And positive 12 works, negative 12 works because negative 12 squared is 144, a positive one. So be careful with that. Both positive and negative work. In number 5, let's switch up colors. I'm getting sick of my red. ZL and measure of angle D is what we want to find. So we want to find this guy and then ZL. Based on what we have here, we see that angle E intercepts LZ. We see that angle D intercepts LZ, and I'm going to outline that. And I guess I'm going to use red again. I love my red. They're intercepting the same arc we can see, so that means they're going to go ahead and be equal to each other. So 3x plus 30 equals 8x minus 15. So that's going to end up being 30 equals 5x minus 15. 45 equals 5x. X is 9. That's a big part to this problem. So we can go ahead and plug in to find angle D. So angle D is 3 times 9 plus 30, or 27 plus 30, or angle D is 57 degrees. And then to find LZ, if this guy's 57, we know this guy's 57. Both those we need to double to get out to this part. So 57, or the measure of ZL, is going to be 2 times 57, or 114 degrees. Okay? So just using that little corollary there. Let you guys finish. Pause if you need to and rewind. Find the measure of angle S and the measure of angle JOB. So S is going to be right here. JOB, this will be a good review of central versus inscribed. JOB is right there. I guess I should keep that as red too. So we want to find that. Let's make this X. Let's call this Y. That'll be better. Find S, find JOB. Okay? So we know that from J to S is 150. And then from, oh, there's my dogs. From S to B is 100 degrees. Okay, so let's do this first and figure out what JB is. Well, we have 360 total degrees in a circle minus 150 minus 100 to get our leftover. Little plus little equals big idea. So we get 360 minus what, 250 is going to be 110 degrees left over. So this guy is 110 degrees. So I don't know why I crossed that off. So we use that there. Now, central angle versus inscribed angle. Central angle is always the same as the arc. So in other words, Y, or we need to label it as I was given the problem, angle JOB equals the same. There's one guy. And then the measure of angle S is always half. So 110 divided by 2, or we would say 55 degrees. Boom, just like that. Center angle versus inscribed. That's a good one to look at for which one is which. 7, little challenging one here. We want to find the measure of angle of ABC. This is going to be from A to B. We always follow it the way it asks us to go. So we want to find that angle. Alright, so we have some work to do. Start with what you know. We know if that inscribed angle is 30, this guy out here is twice that, or 60. If this angle here is 65, then this guy out here is going to be 130 degrees. Okay, we need to find angle the measure of ABC still. So you can actually do this based on what you already have. Always pay attention to those semicircles. When you see that diameter, we know we have semicircles. In other words, we know that if we take 180 degrees, which is this whole thing, minus 60, we get our leftover here. So that is going to be used, and we're going to say that this guy is 120 degrees. And that's from here to there. Okay. Now to find the measure of angle ABC, go ahead and add those guys up. Measure of arc ABC is 120 plus 130, or we would say reduced, that is 250 degrees. So again, little plus little equals big idea. These aren't overly complicated setups or problems, but you got to be careful with how you label your arcs. I would encourage you to use colors. Do not use pen. You never use pen in math anyway. You shouldn't be. But make sure you're using pencil so you can go back and erase and use colors if you need to do that as well. Okay. One last thing. Inscribed quad theorem. So inscribed means the quadrilateral is touching the edge of the circle in 4 different spots. So it fits inside. It doesn't have to be a square or rectangle. It could be any sort of quadrilateral. And if a quadrilateral is inscribed in a circle, then its diagonals are supplementary. It's been a while since we've done that. In other words, this angle, B and D are supplementary, A and C are supplementary. So we would say that angle A plus angle C equals 180. Angle B plus angle D equals 180. So, if we look at this first one, find the measures of K, M, N, and C. So we got to find all of them. So all we have right now is M and C. Well, we have K, but we have no N. So let's compare M and C. And again, they're not equal. They are supplementary. So we're going to say 6x plus 20 plus 3x plus 25 equals 180. 9x plus 45 equals 180. 9x equals 135. 135 divided by 9 is going to give us 15. So there's x. Let's use it anywhere we can. So we can go ahead and plug in. So I'm just going to punch this on my calculator, so you should be doing the same thing. Double check, make sure I don't make a mistake. 6 times 15 plus 20 is going to give me 90 degrees. Doesn't matter if it looks like it or not. No, I'm sorry, not 90 degrees. 6 times 15 is 90 plus 20. It's 120 or 110 degrees. Good thing you guys were following me there. 10 times 15 is 150. Minus 69 is going to give you, this guy's 81 degrees. 3 times 15 is 45, plus 25 is going to give you 70 degrees. Okay. So we know 3 of the angles. A couple of different ways you could find out angle N. You could do 360 minus what you have. You could also say that K and N are supplementary, and let's call this maybe Y and say that angle N is going to be equal to Y plus 81. Alright, so we have, oops, why did I say that? 180 is equal to Y plus 81, or 81 plus Y, because those two angles are supplementary. So Y is going to be 99 degrees. You could also, like I said, just gone around and said, alright, 360 minus the other 3 angles gets me my leftover. Either way works. And let's save number 9 as a nice little warm-up for tomorrow. We got some intercepted arcs, some inscribed angles, we got some central angles. It'll be a nice little warm-up for the beginning of class. Adios.